Hi all, Dmitry is here, and in this, I hope, short video, let's talk about memory effect on modern nickel metal hydride batteries. First, let's do some test. Here I have one of my digital cameras, and as you can see, it turns on. It's working. Okay. And here I have 4 nickel metal hydride batteries in charger, and as you can see, they already fully charged. Capacity is should be 2500 mAh. Let's do some test. Okay, let's install these freshly charged batteries in the camera and try to turn it on. And as you can see, it blinks with low battery indication. But how it can be? These batteries are just from the charger. So maybe they too old and they maybe lose it capacity to almost zero. Let's quickly check how capacity we have here. Let's check the remaining capacity in that cells. First one, 0.5 amps. Let's go. Okay, so what we see for the first cell, at least, capacity is 1500, almost 600 mAh. It seems to be not like new, but it should be enough to at least turn the camera on. Okay, let's check another cells. Maybe just one of other cells failed. Second cell, same parameters. Second cell seems to be good. Let's check third one. Discharge finished, and as you can see, third cell is not new, but capacity looks okay. So let's check the last one. Okay, and last test is finished, and as you can see, we have decent capacity here, and this was on half of ampere. So these cells provide more capacity than cheaper alkalines, but for some reason the camera not even turns on with fully charged cells right from the charger. What's happening? Let's try to figure it out. Here is my explanation, not too scientific, but I think it should be understandable. This is normal situation inside the cell when you charge it or discharge it. This is an electrode, and this is crystals of active elements. This crystals is formed when you charge the battery, and when you discharge it, this crystal is dissolved in the electrolyte, and because of that energy can be stored and used. Because of that crystals are tiny, there is a really lots of them, and there is a space within that crystals, so electrolyte can flow here. Surface area of this, let's say, sponge of that crystals are really huge. So when you apply high load, there will be high current and low voltage drop. All seems to be good. But if you use, for example, quick charger, if you overcharge your batteries, you use not perfect charger, if you overheat your batteries, so during the normal usage, from time to time it can be that you have not separate crystals like this, but you have a really dense structure like this without spaces between crystals, so electrolyte cannot flow inside it, and you have only this surface area. In this case you still have same amount of capacity like here, but in this case if you will try to apply high load, there will be significant voltage drop. So because of that, camera thinks that battery is empty because voltage is too low. But there is a capacity actually. Can we somehow fix it? I think yes. I think there is a way to fix it. This structure, this big crystal, will be dissolved to something like that if we will fully discharge the battery, but difference is this will be dissolved really slowly. So what we need to do is fully discharge the batteries with NiMh like I did, or with some other load. And here is important moment: we must discharge them one by one, not in series, because as you saw before, capacities is not equal from one cell to another, and if you will try to fully discharge them in series, some will be depleted first and then they will be, let's say, reverse charged, so you will damage and fully kill them. If you want to recover them, just discharge them separately, cell by cell, and after they fully drained in charger or in some load, you need to do next thing. So what you need to do to recover the cells is discharge them fully one by one. I will use my multimeter for this in current measuring mode. Again, they was previously discharged in NiMh. You can do this in some other device, in some other load perfectly if it will be devised for just one cell without too much digital electronics. And after they was fully finished, you just need to short them with the multimeter in current measuring mode. So as you can see, there is some current, and it will quickly decay to almost zero, and you will need to leave it like that for 10 maybe more hours until your current will drop below 5 milliamperes or 3 milliamperes or so. So you need to wait, and you need to repeat this process for all 4 cells. And after almost a day, current for this cell is dropped below 2 milliamperes. So I think this is enough for this one. After that, just put this one, the discharged cell, in the charger and make sure that charging current is low as possible. So do not use quick chargers, use slow ones, and use intelligent ones that will stop the charging after the cell will be fully charged. And just repeat this procedure with all cells that you have. I have 4 of them, and let's see what happens. Finally, we are finished all deep discharge and recharge cycle for all 4 batteries. Let's test if this makes some sense or not. Here is my camera again. As you can see, it's turning on. Let's try to install our deep discharged cells here. and check if this makes some sense or not. Okay, looks like not. It looks like probably we need to do another round of deep discharge. Stand by. I did another deep discharge cycle, and then let's take a look what do we have now. Okay, camera is starting. Let's install our cells. So, as you can see, there was bad contact at first time, but then camera began to start. But initially it shows low charge because voltage depression is still there, and when it's trying to shake sensor, battery voltage drops. But now, as you can see, it's showing. Let's focus. It's showing full battery, and it all seems to be good. So, if you have nickel metal hydride cells and they seems to be dead, most likely they can be recovered with deep discharge cycles like I did here. Because typically nickel metal hydride cells have lifespan about 1000 cycles, so if you will recharge them one time per 3 days, you will need about 10 years to fully wear out these cycles. So probably if you have dead cells you can revive them, but just don't use quick charger. Use charger with current equal or less than 10% of capacity. For example, for 200 milliamp hours your charging current must be 200 milliamps or less. Oh, sorry, for 2000 milliamp hours your charging current should be 200 milliamps or less. So do these deep discharge cycles at least 2 times per year, use low charger, and you'll be fine. Thank you for watching, and I hope if you will try to do something like this, you will succeed. So thank you and goodbye.